Every machine NASA sends to another planet comes with an expectation attached to it. Not a guarantee exactly, but a number. A point beyond which the engineers who built it will shrug and say, well, everything after this is a gift. For Opportunity, that number was 90. 90 Martian days, 90 souls of driving across a rust-colored plain, sampling a few rocks, and then quietly freezing to death as the dust settled on its solar panels and the power drained away. It lasted nearly 57 times longer than that. Opportunity landed in 2004 and did not fall silent until 2018. It drove 45 kilometers across a world where nobody could come and fix it. It broke a shoulder joint, lost a steering actuator, went blind in one instrument, and eventually developed something that mission controllers themselves started calling amnesia. And it kept going anyway. This is Today in the Space World, and in this episode, we're following Opportunity from the crater it fell into by accident, all the way to the storm that finally buried it. Opportunity's mission began with a piece of luck so absurd that engineers still bring it up 2 decades later. The lander bounced across Meridiani Planum wrapped in airbags, tumbled, rolled, and came to rest inside a small crater roughly 22 meters across. Out of an entire landing ellipse covering dozens of kilometers of flat, featureless terrain, the rover had dropped straight into one of the very few holes in the ground. Mission controllers called it a hole-in-one. The crater was named Eagle, and it mattered because craters are windows. On a planet where wind has spent billions of years smoothing everything into monotony, an impact crater cuts down through the layers and exposes what's underneath. Opportunity had landed with the geology already laid open in front of it. What it found on those exposed walls changed the way we talk about Mars. Fine layering in the bedrock of the kind you get when sediment settles in standing water, sulfate minerals that form in wet conditions, and scattered everywhere across the surface, tiny grey spheres, millimeters wide, embedded in the rock like seeds in bread. The team nicknamed them blueberries. They were concretions of hematite, an iron mineral that, on Earth, generally forms in the presence of water. Within weeks of arriving, Opportunity had gathered strong evidence that this patch of Mars had once been soaked, not comfortably, not pleasantly. The chemistry pointed towards water so acidic it would have been hostile to most life we know of. But wet is wet, and wet was the entire question. Then Opportunity climbed out of Eagle Crater and started driving. It spent half a year working its way down into a much larger crater called Endurance, reading the rock layers like pages. It found an iron-nickel meteorite sitting on the sand, the first meteorite ever identified on another planet. And in 2005, it got itself thoroughly, embarrassingly stuck in a sand ripple that the team named Purgatory. Freeing it took 5 weeks of careful, centimeter-by-centimeter wheel commands from a control room 200 million kilometers away. The 90-soul warranty had long since expired. Nobody was thinking about it anymore. By 2008, Opportunity had finished with a crater called Victoria, a hole roughly 750 meters wide that had taken 2 years to reach and explore, and the team made a decision that, on paper, looks close to reckless. They pointed the rover at a crater 19 kilometers away in a straight line and told it to drive. Endeavour Crater is 22 kilometers across and something in the region of 4 billion years old, which makes it far older than anything Opportunity had studied so far. Older rock means access to an earlier and possibly gentler chapter of Martian history. The problem was the distance. In 4.5 years of operations, Opportunity had covered around 12 kilometers in total. This single drive would be longer than the entire mission so far, across open plains, with a rover that was already limping. It took 3 years, and by the time it was done, the odometer had logged more than 21 kilometers of actual driving. Opportunity finally reached the rim of Endeavour in 2011, at a spot the team named Spirit Point, in honor of its twin rover that had fallen silent on the other side of the planet the previous year. And almost immediately, the gamble paid off. Sticking out of the ground was a bright vein of mineral running through the rock, roughly the width of a thumb. Analysis identified it as gypsum, a calcium sulfate that forms when water flows through a fracture and deposits dissolved minerals along it. This wasn't ambiguous. This wasn't inferred from grain shapes. It was a physical scar left behind by moving water, and crucially, the chemistry here pointed towards water that was far less acidic than what Opportunity had found back at Meridiani. Later, on a ridge called Matijevich Hill, the rover identified clay minerals that only form in neutral, drinkable water. On a rock called Esperance, the signal was so strong that the mission's principal investigator described it as the most powerful evidence for water the rover had produced in 9 years of work. Endeavour was giving up a version of Mars that was older, wetter, and far more hospitable than anything the mission had seen before. So, Opportunity stayed. It would spend the rest of its life working its way around this single crater rim. Machines don't age the way we do, but they age. By the middle of the 2000s, Opportunity's list of injuries was long. A shoulder joint in its robotic arm had failed years earlier, forcing controllers to drive with the arm permanently unstowed, like a broken limb held out in front. The steering motor on its right front wheel had jammed back in 2005, and the left front would eventually fail the same way in 2017, which left the rover driving backwards for much of its later life. The Mini-TES instrument, which read the mineral composition of rocks from a distance, had been contaminated with dust during a storm in 2007 and never worked properly again. The alpha particle spectrometer, once capable of analyzing a sample in a matter of hours, now needed days. And then, through 2014, Opportunity began to forget. The rover's flash memory, the storage that survives a power cycle, the equivalent of a hard drive, started failing. The symptom was a sudden, unexplained reboot, sometimes several in a single day. Each reset interrupted whatever the rover was doing and put controllers back to square one. Engineers worked the problem from Earth and eventually identified a specific bank of memory cells that appeared to be the source. They reformatted the flash drive remotely and instructed the rover to route around the damaged section. It helped, it didn't cure it, so they made a hard call. They switched Opportunity into RAM-only mode. RAM is volatile. Whatever sits in it disappears the moment the machine powers down, and Opportunity powered down every single night to survive temperatures that fall far below -70 degrees Celsius in the Martian dark. From this point on, any data the rover collected during a day but failed to transmit before nightfall was gone permanently. Every observation became a race against sunset. It is worth sitting with what the team was working with here. A solar-powered vehicle, 11 years past its design life, with a locked wheel, a broken arm, degraded instruments, and no long-term memory, being driven up and down crater slopes by people who would never see it again. And they were still doing real science with it. In March 2015, Opportunity crossed a line that nobody had drawn for it. Its odometer passed 42.195 kilometers, the exact length of a marathon. It had taken 11 years and 2 months, which is not a competitive finishing time, but is a considerable achievement for a machine that was supposed to drive about 1 kilometer and then die. Back on Earth, the team ran a relay marathon of their own to mark it. The valley opportunity entered around this milestone was named Marathon Valley in return. A year later, working the southern wall of that valley, the rover attempted the steepest drive of the entire mission. Pushing uphill towards a target near the crest of Knudsen Ridge in 2016, Opportunity tilted to 32 degrees, the steepest slope any rover has ever attempted on Mars. It didn't make it. The wheels turned enough to have carried it 20 meters, but the surface was so loose that the rover advanced roughly 9 centimeters. What it gained instead was power. Angled that sharply towards the sun, the solar panels were pulling in close to 600 watt-hours a day, better numbers than the rover had seen in a long time. Marathon Valley had been chosen from orbit. The Mars Reconnaissance Orbiter had detected clay signatures here from space, and the ground team wanted to know what those clays looked like up close. Opportunity found rocks that crumbled far more readily than the tough outcrops it was used to, with compositions unlike anything else in the region. It took well over a year to work through the valley because everything was slow now. Slow instruments, slow analysis, a computer that could reboot without warning, but it worked. Then the rover pushed south through a gap in the rim, down a valley and on towards the target that the team had been circling for years, a gully. Gullies are shapes that suggest flow. Something ran down them. On Earth, that something is almost always water. No Mars mission had ever examined one from ground level, and Opportunity was now in a position to be the first. The team named it Perseverance Valley. The rover arrived in 2017 and started reading the terrain, looking for the signature of ancient water against the alternative explanations of wind or ice. It found stones lining the channels. It found textures that could be interpreted several ways, and in the end, it never got a clean answer. In the middle of 2018, orbiters spotted a dust storm forming on Mars. This is normal. Mars produces dust storms the way Earth produces weather fronts, and Opportunity had already survived several. But within days, it was obvious that this one was different. It expanded, merged, and kept expanding until it had wrapped itself around the entire planet. The numbers tell the story better than the images can. Astronomers measure atmospheric opacity with a value called tau. The worst storm Opportunity had ever endured, back in 2007, reached a tau of 5.5, and that had nearly finished it. This storm reached 10.8. From the surface, the sun would have been reduced to a faint smudge if it was visible at all. Opportunity's power collapsed. When the darkening began at the end of May, its batteries were delivering around 645 watt-hours a day. 4 days later, that had fallen to 133. Science operations were suspended on the 8th of June, and on the 10th, the rover sent its final transmission. A status report showing an energy level of roughly 22 watt-hours and a last, almost entirely black image of a sky it could no longer see through. Then it went quiet. The storm lasted months. When it finally cleared, mission controllers began calling. They called for 8 months. They sent over 1,000 commands. They tried during the windy season, hoping a gust might sweep the panels clean. They played wake-up songs in the control room for a machine that couldn't hear them. In February 2019, NASA formally declared the mission complete. Opportunity had operated for 5,111 sols. It had driven 45.16 kilometers, further than any vehicle has ever driven on another world. It had returned more than 200,000 images, and it had turned a hypothesis into a fact. Mars was once a wet planet, with standing water, flowing water, and chemistry mild enough that life would not have been immediately impossible. A rover built to survive 90 days spent 15 years proving it. 90 days was the promise. 15 years was the answer. Subscribe and stay with the machines that refuse to stop talking.